video. In this video we are going to talk about the work done by different forces. Consider a mass M, this is a mass M, on a rough surface pulled by a force F in the direction of positive x-axis. Just the dashed line is representing the final position of the mass, and it travels through displacement of S. So we know the surface is rough and it's horizontal. So whenever the surface is rough, meaning it has some surface has some coefficient of friction, and whenever you apply a force F in this direction, so the friction resists your motion in that way, then the applied force is this F minus the frictional force is going to be the resultant force. We know the frictional force is given by the coefficient of friction times the normal force, the F normal. In such case, the normal force is how much? It is the weight of the object. Yeah. Now, from this, we have the following. So the force applied minus frictional force gonna give us the what? The resultant force. The resultant force or the net force. The net force. So we can have the expression for the applied force. The applied force is equal to how much? The resultant force Fr plus the frictional force. Now this is the expression for the force you apply on pulling the mass through that distances. Now but what we know is the force applied and the displacement are parallel, you can see, so there is no cosine something. So the force, the work done by the applied force is equal to the force applied times the distance. But the force applied is equal to how much? The resultant force plus the friction force. So this is the work done, the applied total work done by the applied force, you can call it total work done, is equal to, instead of the applied force we can use the resultant force plus the frictional force, everything times the distance. Okay, now we can distribute the force, the distance into the bracket. So the work done by applied force, the total work done is the resultant force times the distance plus the frictional force times the distance. But this is called the force resultant times the distance is called the work done by the net force, and plus the frictional force times the displacement is called the work done by against friction. So the work done by the total force is equal to the sum of the work done by the net force and the work done against friction. Now look, we know the work done by the net force is how much? The work done by the net force is the net force or the resultant force times the distance, and this is equal to how much? The mass times acceleration is the resultant force times the distance. So this is how much again? You can say this is equal to the mass into the v minus u over t for acceleration, and the distance is the v plus u over 2 the average times the time. You can cancel the time. This t cancels this one. So the work done by the net force is equal to how much? The mass times the v minus u into the v plus u over 2. As we have already mentioned in the previous videos, this is equal to how much? The mass over 2 times v minus u into v plus u is the difference of 2 squared. So that's v squared minus u squared. So the work done by the net force is equal to how much? Half of the mass into the v squared minus u squared. So this is equal to how much? Then we can distribute the work done by the net force is equal to how much? Half times the mass times the v squared minus half times the mass times the initial velocity squared. So but half times the mass times the v squared is how much? It is the final kinetic energy. So the work done by the net force is equal to the kinetic energy final minus the kinetic energy initial. Or you can say the work done by the net force is equal to how much? The change in kinetic energy. So meaning the work done by the total work done is equal to the increase in kinetic energy of the mass plus the work done against friction. This is very important thing to note regarding to work done by variable forces. Now let's work on work done against friction. So the work done against friction is how much? It is the frictional force times the distance. Actually, we know the work done against friction is usually negative. So for a mass on a horizontal surface and pulled by a horizontal force, we know the normal force is the weight, the mass times gravity, and the frictional force is how much? The mu times the normal force. So this is the same as the mu times the mass times gravity. So the work done against friction is equal to the mu times the mass times gravity times the distance. So this is the work done against friction. So the total work done, the total energy transferred to the mass, transferred to this mass, the total energy transferred to this mass is the work done basically by the help of this force, is the mechanical work done, is equal to how much? The work done by the total is equal to the change in kinetic energy plus the work done against friction. Or this is equal to the work done total is equal to the work done against friction. The work done to change kinetic energy is how much? The mass times the acceleration times the distance, plus that one is the frictional force times the distance. You can rewrite this as the work done by the total is equal to the mass times acceleration times distance plus the coefficient of friction times the mass times g times the distance. So this is the work done against friction. So that is the total work done. Now let us see this with examples. So example, a mass of 10 kilogram on a rough surface, coefficient of friction 0.4, and horizontal surface is acted by a horizontal force of 100 Newton as shown below. Now there is a mass here. This is the mass. So the mass is 100 kg, 10 kg. Then the 10 kg mass is acted by a force of 100 Newton, and the initial velocity is 0, meaning initially was at rest. Then after the application of this force, the mass starts to move and it comes to this point, which is a displacement of 20 meters, and it's gonna have some final velocity v. We're about to do the velocity finally later on. So this is given, this is given. So the thing we are going to find out is, so find the resultant force, frictional force. This is the frictional force, this is the kinetic energy initial, this is the kinetic energy final, the total work done, the net work done, the work done against friction. Let's start with the frictional force. It's better to start with the frictional force. So the mass is on a horizontal surface, therefore the frictional force is given by mu times the normal force, but the normal force in this time is how much? It is the weight. So the frictional force is how much? The mu times the mass times gravity. So this is gonna give you 0.4 times 10, the mass is 10 times 10 again, so this is gonna give you 14 Newton force. This is the frictional force. Get the resultant force. This is the first thing you do. The resultant force, the force resultant is how much? The applied force. The applied force F minus U minus the frictional force, that is the 100 Newton minus the 40 Newton. So this is gonna give you 60 Newton. So the resultant force, which is responsible for the increasing its velocity, is this 16 Newton force is acting on it. The next thing is to find the kinetic energy initial. So the kinetic energy initial is equal to half times the mass times the initial u, the initial speed square. But the initial speed is 0, so half times 10 times 0 will give you 0 joule. This is the initial kinetic energy, 0 joule. Then find the kinetic energy final. To get the kinetic energy final, so we need to get what? You need to get the velocity, the speed final. So the kinetic energy final is gonna be how much? So it is half times the mass times the final speed square, yes. But we don't have the final speed square. But there are two ways of getting this kinetic energy final. Okay, how do we get this kinetic energy final? Before that, how do we get the speed? Okay, so I can use the concept of the above discussion. I can find what the work done by the net force is how much, which is equal to the work done by the net force is equal to how much? The force resultant times the distance, yes, times the distance. That is the force resultant is 16 Newton. The distance is 20 meters. So this is how much? It is 1200 joule is the work done by the net force. But what do we know? The work done by the net force is how much? The work done by the net force means the work done total. The work done by the net force is equal to how much? The change in kinetic energy. Yeah? So that is the kinetic energy final minus the kinetic energy initial. But the final energy is the final kinetic energy is required. So the work done by the net force, is equal to the kinetic energy final. Okay, the kinetic energy final, because the kinetic energy initial is 0. So this is equal to how much? The work done by the net force is 1200 joule. So that is the kinetic energy final. So how do I get the final velocity? The final velocity you can get from this one. But kinetic energy final is how much? It is half times the mass times the v final square. So 2 times the kinetic energy final, alright, divided by the mass, gonna give you the square of speed. This is it. So this is gonna be how much? This is gonna be 2 times the kinetic energy final is this much over the mass is 10. So this is gonna give you the v square. Then this is equal to how much? So the v square, this shows the v square is how much? The v square is, so 10 you can 240, yeah, 240 meter square per second square. So to get the v, you can use the square root of that 2400, 240 meter per second. So this is the speed at the final. The work done against friction is equal to the frictional force times the distance. Yeah. So the frictional force is already calculated. It is how much? It was mu times m times g, 0.4 times 10 times 10. That was 40 Newton. 40 Newton times how much? 20 meters. This is gonna give you 800 joule. So this is the work done against friction. Remember, the work done by the net force is how much? It was 1200. So this is the work done by the net force. So the work done by total is equal to the force times the applied force. The work done by the applied force. The force applied times the distance is how much? 100 Newton. 100 Newton is the force times the distance is 20 meters. Yeah, this gives you 2000 joule. Okay. So this is 2000 joule, or you can do the work done by the net, the total work done. The work done total is equal to the work done by the net plus the work done against friction. You can add this two. So this is 1200 plus 800. That's going to be the same 2000 joule. Okay. So that is the total amount of work done. The idea here is the mass is pulled by on a rough surface is applied by a force F. So there's a mass M. So the force F displaced the mass through a distance of 20 meters. Yeah. Now the idea here is through this force, some energy is transferred to the mass. Okay, to the mass. So the mass gonna possess the energy transferred to the mass by the help of this force is on the mass in the form of increasing kinetic energy. Part of the energy transferred to here by this force goes to increasing kinetic energy on the mass. The other it turns to heat by what? By the friction on the surface. So the very important thing to note here is the work done by the net force. By the total work done. The total work is equal to the change in energy, actually kinetic energy, plus the work done against friction. So this is a very important principle or rule to apply in solving problems. Thank you for watching this video. Please don't forget to subscribe. Second example, how much work is done by the applied force, the net force, against friction for a 10 kg body on a horizontal and rough surface, coefficient of friction 0.4, acted by 120 Newton force at an angle of 37 degrees above the horizontal in displacing it by 8 meters as shown below. So this is a good example to show you how much energy is transferred to this mass by the help of the 120 force mechanical work done. So this work done is part of the work done is on the mass as increasing kinetic energy of the mass, and the other part of the work done is gonna be run out into heat due to the frictional resistance of the surface, because the surface is rough. In A, we are looking for the work done by applied force, WA. So the work done by the applied force, WA is given by what? So WA is given by WA work done. WA, the work done what? Work done by applied force is required that here. Okay, so what's given here? So the force is given. The force is given to be how much? It is 120 Newton, and the displacement is given. It is how much? It is 8 meter, and the angle is given theta, which is 37 degree. From this one, you can have sine of the angle. So these are given. The work done by the applied force is required. So this is equal to the force applied times the cosine of the angle. The cosine of the angle times the displacement. So this is equal to how much? 120 Newton times 0.8 times 8. So you can write this as 10 times 10. You can 12 times 10. You can do 120 as 12 times 10 times 0.8 times 8. But 10 times 0.8 give you 8. So this is equal to 12 times 8 times 8. So this will give you 12 times 64 years. So this will give you 768 joule. That is the work done by the applied force. In the case of B, we are looking for the work done by the net force. Okay, to get the work done by the net force, there are two ways of doing this. One is you should find the net force first, then after that the work done by the net force is the net force times the displacement. Now the other way is you can calculate the work done against friction first, then you can do the difference of the work done total and the work done against friction is the work done by the net force. Now let's find the resultant force. So the resultant force this time is equal to how much? This component of the force, Fx, which is F times cosine of the angle, minus what? Minus frictional force. The frictional force is resisting in the opposite direction. That's the frictional force direction. So first we have to calculate the frictional force. You can have the rough sketch of the mass. So there is the F like that, there is the Fx like that, there is Fy here. So this is the Fy, that affects the frictional force. It is a weight down mg, and you can have the normal force upward. So you need to calculate the frictional force first. The frictional force is equal to the mu times the normal force. Okay, the mu is given to be 0.4 years. So the mu times normal force. But how do I get the normal force? The normal force this time is the weight is downward, the Fy is detaching upward. So the normal force is the difference of this one, the attaching and the detaching Fy. So that is the weight mg minus Fy. But how much is Fy? So Fy is how much? Let me change the color. So Fy is F times sine of the angle. So F is how much? 120 times 0.6 is sine of 38. So this will give you 72 Newton. Okay, so the weight is, the mg is how much? The mg is, let me change the color back. So the mg is how much? 10 times gravity 10 minus 72 is the y component. So this is equal to how much? 100 minus, yeah, this is equal to the F normal is equal to 100 Newton minus 72. So the normal force is 28 Newton. So that's the normal force. All right, now let's have the frictional force. So the Fx is F times cosine of theta. F is 120 Newton times 0.8. This give you how much? As we have done on the previous one, this will give you 96 Newton. All right, the normal force is this much. Now let's get the frictional force. That's mu times the normal force. So this is equal to is how much? 0.4 times mu is 0.4, and the cosine of normal force is 28 Newton. So this gonna give us how much? 11.2 Newton. Okay, that's the frictional force. All right. So the net force or the resultant force is equal to how much? the Fx minus the frictional force. The Fx is 96 Newton minus 11.2 Newton. So the difference of this 84.8 Newton. That is the resultant force. Now let's calculate the work done by the resultant force. The work done by the net force is the resultant force times the displacement. So this is how much? 84.8 Newton times the displacement is 8 meters. So this will give 678.4 joule is the work done by the net force. Now let's calculate the work done against friction. So the work done against friction is required on C, but we have already calculated the frictional force is equal to 11.2 Newton, and the displacement is, we know it is 8 meters. Okay, so the work done against friction is usually negative because it is angle is 180 degrees. You know, the direction of the displacement is this way and the friction is resisting the other way, so this makes 180. Cos of 180 is how much? It is -1. So usually the magnitude of the work done against friction is what? Negative. Okay, this time we need the absolute value of the work done against friction. So this is equal to how much? The frictional force times the displacement. So this is equal to 11.2 Newton, the force, times the displacement is 8 meters, and the work done against friction this time will give you how much? 89.6 joule. That's it. So this is the work done against friction. So you can check this one. The work done by applied is equal to the work done by the net plus the work done against friction. Yes, check this one. This is your assignment, because the work done against friction is this much. The work done by the net force we have done earlier is 678.4, and the work done by the applied force is how much? It was 768 Newton. So check whether this sum is equal to the sum of this work done against friction and the net force is the same as the total one, this one.